Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay. The longest wavelength of light that will cause emission of electrons from cesium is 653 nanometer. Nano standing for 10 to power minus 9. Okay. Part A. Compute the work function for cesium phi. Okay. Part B. If light of 300 nanometer ultraviolet were to shine on cesium, what would be the energy of the ejected electrons? Dear students, this problem is enough similar to our previous problem. Okay. The main difference, one difference is that in previous problem work function of cesium was given. Okay, in statement it was given 1.90 electron volt, and our table was showing 1.95 electron volt as work function of cesium. Okay, and similarly there in part B there was a wavelength 300 nanometer, while in part C wavelength was 400 nanometer. Okay, so anyhow it is quite clear that this problem is enough different from previous problem, but also similar to some extent. Okay, so we will give less time to similar things which have been covered in previous problem. Okay, before starting its solution in a formal manner, we will have to go through a few snapshots which were also included in previous problem. So we will skip those snapshots for the time being. Okay, first snapshot, table of physical constants. From here, this value, that is combined value of a Planck's constant h and speed of light c, is the most relevant. Okay, anyhow we skip this for the time being. Second, work function of different elements in which cesium 1.95. Okay, we are skipping this snapshot. Okay, third snapshot about photoelectric effect, EV not equal to EV not equal to HF minus phi work function. Okay, we are skipping for the time being. Next, table of Greek alphabets in which phi is the most relevant. We are skipping this snapshot for the time being. Next, some detail about work function. We are skipping this snapshot for the time being. Okay, now we are going to our solution in a formal manner. First we are starting part A of this problem. Okay, part A, we know that threshold wavelength is given as lambda t equal to hc over phi. Okay, this implies that from here, if we want to find out the value of work function phi, then phi will be shifted on other side of equality, and it will become it will appear as in a numerator from denominator. And similarly, threshold wavelength lambda t, which is primarily in the numerator, will be shifted to denominator after being shifted on other side of equality, and our work function phi will become equal to hc over lambda t. Okay, dear students, in our first snapshot in which various physical constants have been given, separate value of Planck's constant h and speed of light c are given, and combined value of hc is also given. Similarly, value of threshold wavelength lambda is provided in the statement, which is 653 nanometer. Okay, so we will just put these two values in this expression, and our answer, that is threshold wavelength, will become equal to 1.8989 electron volt. Okay, now we are going to part B. We know that maximum kinetic energy of photoelectrons is given as E max equal to E Vs equal to E HF minus phi equal to HC over lambda minus phi, where E Vs is the stopping potential. This implies that K max is equal to HC over lambda minus work function phi. Okay, we will just put the values. Value of HC is given in the table, which we have included as a snapshot number 1 in this problem in this video. Moreover, value of wavelength lambda is provided in the statement, which is 300 nanometer, and value of work function, which we have calculated in previous step, is 1.8989, while in the table which we have shown as a snapshot in this problem, value of work function is given as 1.95. Okay, so 1.95 or 1.90 or 1.8989 are very close to each other. So whichever value we put, we will reach the almost exact answer. Okay, but here, because we have calculated this value 1.8989, so we will use this value here instead of 1.90 or 1.95. Okay, so using this value from table, this value from statement, and this value from our part A, we find K max equal to 2.23 electron volt. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.